Hello, my name is Sean Bennick, and I'm going to talk to you a little bit about what the Aerospace Enterprise is kind of up to nowadays. So, without further ado, let's kind of get into it. So, who are we? Well, we are the Aerospace Enterprise. We are an enterprise here on tech that focuses to educate the future leaders of the aerospace industry. We do this by providing space systems engineering projects uh, through experience, design, testing, and integration of spacecrafts that will properly go to orbit. Along with this, we seek to advance U.S. space technology by solving real-world problems. This is not just a science fair project that's currently staying on Earth. We will be going up, we will be conducting science research that is helping current day modern technologies, and then we will be using this and posting in academic journals as needed. So a little bit about our program. We were founded in 2001 by Dr. Brad King, our academic advisor. We have helped over 400 students complete a senior design project and graduate on time. Current students are about 78 active members and continue to grow each semester. Another fact that we're very proud of is that we take everybody from across campus. So we are proudly home to over 13 different majors of undergraduate majors here at Tech. Along with that, we have two facilities on campus. We have two in the meme, a lab called the Aero Lab, which is in the basement. You can see in the top right-hand corner, and the clean room you can see in the bottom right-hand corner, which is our clean room kind of facility so that we can keep all of our space-grade hardware and make sure that it's not damaged by any outside contaminants. Along with this, we are funded by two well-known, well-established academic aerospace companies, the Air Force Research Laboratories and NASA. And in the past, we have launched a satellite, and we have more on the way. Speaking of more on the way, our current orbital missions that we are building, integrating, and sending off into flight are our Auris mission and our Stratus mission. Auris is understanding the geo emissions, the RF emissions from geostationary satellites to Earth, and be doing scientific research based off of these different signals as they come down to Earth. And Stratus will be taking pictures of clouds to get different data and help overall climatology models, and then also kind of just help solar irradiance patterns. So a little bit of background for Auris. So with the commercialization of space, the space environment grows ever more busy and more as more and more companies send up satellites to do scientific missions. So Auris is helping make this more manageable. We are going to help understand where these satellites are and what they're doing at that point in time. Well, how are we doing this? Well, the Auris spacecraft is a low-cost platform that will be exploring the interference potentials of geostationary satellites through their physical and their electrical interferences with each other. The way we'll be doing this is with two objectives. The first being beam maps. So as we fly through the as we fly through the RF antenna beams of these satellites in geostationary orbit, we'll be taking in the timestamp, the GPS, and the signal power at each different uh, collection location. As we do this, we will be able to run it through our onboard custom payload system in order to understand where the signals are strongest, where it's weakest, and overall the data that it makes while it's the footprint that it makes over the US. Our second objective will be multilateration, or MLATs. This will be taking in that time stamp value at our Auris location and at three different locations on ground. And as it does this, it will be able to backtrack exactly where that source of emission is to about a 50-kilometer ellipsoid of confidence. So let's switch gears and kind of talk about our Stratus mission. So as Stratus flies overhead, we will be taking pictures of clouds in different areas in order to understand the average cloud coverage in that area and better help our climatology models. So we will be taking in these pictures, we will be parsing it out so that we know exactly what pixel is a cloud and what is ground. And then we will be able to make these models over longer periods of time to help us overall understand the climatology models and also understand where it's a good place to put solar panels, anything like that. So those are our two current orbital missions. So I'll quickly run through our two on-ground or in-atmosphere missions that we're also doing. So our Descensus mission is a CanSat mission, which means it is a satellite about the size of a can. It is funded by NASA, and it does small in-atmosphere research to help better advance U.S. technology. So this year they are using a CanSat to slow its descent using an autogyro system. And as it does this, it will need to maintain connection with our ground support team. It will also need to configure itself into a pointing direction north. Alongside of this, it will also need to take video and remain in comms as the entire mission proceeds. And lastly, but not least, we have our Connexus mission, which is a server database that we are building in order to help us track personnel, inventory, and finance trackers across the entire enterprise to help better accountability and hopefully just kind of help organize the enterprise as a whole. Here are some of the different subsystems that we are hoping to implement into this Connexus server. And from simulation to inventory management to personnel tracking, the server should be able to do it all and be able to help organize the enterprise the way that we hope it should be. For the Connexus timeline, we're looking at getting a minimal viable product by the end of spring of 2026, and hopefully this mission will never be shut down as it'll be a ever-evolving project that the enterprise will be a part of. So a little bit about some of the recent progress we've been doing. So before we jump into that, we'll kind of talk about how to build a satellite. Building a satellite takes many steps. So you have to go from your mission concept for what you want the bare bones the satellite to do, moving into requirement definition, being able to set aside and decide how it's going to do these different mission steps. And then you have to work all of it in together to do system design, and then once you have your system design, you can start to integrate it and test it. And then finally, once you've done that for both an engineering model and a flight model, you'll be able to launch it on a rocket or some other means of getting it into space, and then you're into mission operations. So where are we kind of at with our current projects right now? Well, for our Auris integration team, they're really focusing on what we're calling the five big tests. These are five tests that will be able to mimic the exact uh, different things that our spacecraft will have to do in orbit. So for our first test, we have to make sure that it configures itself in a proper pointing position to make sure that it will maintain the optimal amount of solar panel uh, coverage and also be able to point down at Earth in order to help us communicate down. And we have a bunch of different other tasks that we need in order to make sure that our system works exactly how it should before we start working with our flight model and testing that up. So we're working on mostly integration for Auris. Stratus is in a very similar spot. Uh, there are Thankfully to the community here at Michigan Tech, we were able to revitalize this mission, and we were able to come back from a uh, dying mission to a fully strong mission. We have the bus in-house. Thankfully, last semester, our full satellite came in-house, and we are doing the software code for it. We're putting some mission code on it, and we'll be able to launch it up shortly with followed by mission operations. So, to conclude, we are the Aerospace Enterprise. Thank you so much to all of our alumni network and all of the student body that currently helps us. We appreciate all of your continued support. And if you'd like to learn more about us, we have a Facebook, we have an Instagram, we have LinkedIn, and we'd love to talk more about it. We also have a website that you can find at Michigan Tech Aerospace Enterprise. Um, if you look that up, we should be one of the first links. So. Thank you for all your attention, and I appreciate uh, everything that Michigan Tech has done for us.